Hello, this is a short video on how to solve right triangles, all right? And we're going to use inverse trig functions in the process in this video. So that's the new trick. So what you should already know is how to solve a triangle where you've been given an angle, a right triangle that is, and let's just say that this angle is 40 degrees. So it's not one of the nice angles. We'll give that a 40-degree angle, and let's just say that this side is 10. All right. First of all, to solve a triangle, it means you want to find every angle and every side. The angles are almost trivial when one angle is given. Actually, you've been given two. You know it's a right triangle, so we have 90 degrees given, we have 40 degrees given, and so we know that the other side must be 50 degrees, the side that's not given. So those are the three angles. So the missing angle is a 50-degree angle. The trickier thing was figuring out the sides. Let's just call those X and Y for now. All right. So you could quickly set up that Y over 10 is the sine of 40 degrees. Therefore, Y is equal to 10 times the sine of 40 degrees. Enter it into your calculator and get an answer. Now, from our lesson today, when you take the sine of an angle, you always get one ratio out. So an angle will lead to a ratio. What we were seeing in class today is when you're trying to go the other way, you need to be careful. So likewise, we can figure out the x side. Okay, so if you just set up the ratio that x over 10 is equal to the cosine of 40 degrees, you could, in a similar manner, solve for what the x value is. All right, then you also had, let me just give you one more example of these. So let's say you had the same triangle and you knew it was 40 degrees, but at this time you were told that this side was 8. Okay, you wouldn't be able to solve this in exactly the same manner as before. You would know the angles are the same as we had, or we're assuming that's a right angle. And so you could set up, let's call this X and R this time. You could set up that 8 over X is the tangent of 40 degrees. And then you can multiply both sides by X. So 8 is equal to X times tan 40. And X would be 8 divided by tan 40 degrees. And once again, you don't have a problem because you have a trig function of an angle, and one angle leads to one ratio. So you get a single answer. And then you can do something similar for R involving the sine function. So 8 would be opposite side, R would be the hypotenuse, and you could solve for R in a similar fashion. What's new in this lesson is when we're not given any angles, okay? So notice in both of these examples, we were given two pieces of information. We were given, well, three, technically it's a right triangle, and we were given one angle and one side. So we had so basically we have two angles and a side given, right? Now we're gonna do cases where we have two sides that are given instead. So we're sticking with right triangles, and the nice thing is that means, whoops, that is my highlighter, not my marker. I'll erase that. So the nice thing is that you will have all of the angles being acute angles. And in our lesson today, we learned that inverse trig functions work very nicely in the first quadrant. All three inverse trig functions work in the first quadrant. And so we won't have any problems with obtuse angles. So let's just say that this side is, let's go with 7, and this side is 4, all right? And we need to solve this triangle. Well, the first thing that you can get all three sides quickly by using a Pythagorean theorem, okay? So let's call this side, I'll call it R again. So I know that 7 squared plus 4 squared is equal to R squared. So getting the third side is going to be easy. 49 plus 16 is R squared. Add them up, 55, 65. So R will be the square root of 65. We don't need to worry about negatives because it's going to be a positive side length. So now let's use the 4 and the 7, though, to figure out the angles. All right, I'm going to solve for this angle here, theta, because it looks like it's sort of in standard position, but there is another angle, let's call that alpha up there that we could solve for. But once we know theta, we can just use the three, theta and alpha have to both be complementary and add to 90. So let's find theta. How do we do that? We'll have to use inverse trig for this. Let me switch to blue here. We can look at the 4:7 ratio, and that would be 4 is the opposite side, 7 is the adjacent side, so this in fact is the tangent of theta. Okay, so we have a ratio is equal to a trig function, but we want to solve for the angle this time. So we need the inverse trig function of both sides. Technically, we usually don't write this step. I'll do this in blue. Technically, what we're doing is we're taking the inverse tangent of both sides. But the inverse tangent is the function that undoes the tangent. So the result of that is you're left with theta. When you take the inverse tangent of the tangent, you're just left with the angle. All right, so that will equal the inverse tangent of 4/7. All right, and you can put this into your calculator and you will get a first quadrant answer. All right, remember the inverse tangent could give us first or fourth quadrant, but clearly this is a positive ratio, so it will end up giving us a first quadrant answer. So that's how you would solve that one. Just do one more. Let's say you had a triangle where you knew that this side was 6 and that side was 7, and you were trying to solve it. Okay, so the first thing you do is get the missing side. Let's call that y this time. And then we're going to try to solve for this theta. Oh, in the previous example, you will also need to say that alpha is equal to theta, or 90 degrees minus theta. Alpha plus theta are 90 degrees. Okay, so that would give you the final angle. So to get the side y here, we would know that 6 squared plus y squared is equal to 7 squared. So 36 plus y squared is 49. All right, and so if we subtract 36 from 49, we will end up, let me make sure I get this right, we will end up with 13. So y squared is 13. Y would be the square root of 13. So that's how you would find the side. Now we want to use the two sides that we know, just in case we made an error. We want to stick with the, whoops, let me change to red here. We want to stick with the original numbers given in order to try to solve for theta. And in this case, we're given the adjacent side and the hypotenuse. So we want to set up a cosine ratio. So the cosine of theta is equal to 6/7. All right. So we want to undo the cosine function to solve for theta. So if we were to take the inverse cosine of both sides, we will find out what the angle is. Okay, and then use the complement to get the other angle. Alpha plus theta will have to be 90 degrees. Let me just write that down. Alpha plus theta, once again, are 90 degrees. So once you get the answer for theta, you will be able to then find out what alpha is. Now remember, an inverse cosine can give you a first or second quadrant answer, but second quadrant answers would be more than 90 degrees, and theta and alpha can't be more than 90 degrees. So the first quadrant answer that you get is the answer, and that will let you solve the triangle. So remember, solving the triangle means to find every side length and every angle. So if you don't have any angles given other than the 90-degree angle, we're working with right triangles, so we know that we have a 90-degree angle. If you don't have a second angle given, you're going to have to use inverse trigonometry in order to figure out what that angle is.